You will have to round, yes. They didn't say in the exercise, but they will in the exercise. Alright. So that's all 1A read. They gave you in 1A, they gave you the radius of a circle. They asked you to find the circumference. So remember, if they are giving you the radius, you use 2 pi radius, right? So that is the formula that I used there. So guys, in a test or exam, you'll get a mark for knowing the formula. So please write that line down. That's 1 mark, okay? Just for memorizing the formula, you have to memorize it though, guys. We're not going to give it to you, yeah?
Yeah, I think they like the
No, you don't have to, no. What? What is the next one? Okay, so here it was 1 mark for the 2 pi radius, 1 mark for actually substituting the value of the radius into that formula, right? The 2 pi times the radius. Remember, I told you you can also write it like this if you prefer, just using brackets. Okay, instead of the time symbol, that's perfectly fine. And then, guys, you type that into the calculator. Let's just quickly go over how you do that again. 2, and then shift and that button to get pi times 83. So, guys, you're going to get 165. But like I said already, that's not really an understandable answer, right? Because what is that? So, press the SD button. That means third to decimal. All right. Now third is like a root. Okay, so you're going to press S to D, and it will give you the decimal value, and then usually we round to 2. Okay, but that they should also actually tell you in that case. But do we agree that this is 5 to 1,50, or just comma 5? Okay, fine. If you just wrote comma 5, they didn't specify how we have to round in this question. Okay, so 5 to 1,5 would have been fine. So that would then be another mark for the answer, guys. Isn't that nice? 3 marks for that question. Okay, and it's literally just knowing the formula, remembering that we times by the radius, and then typing it into the calculator. Useful? I said already you can write 5, 0, or 5. If they take to 2 decimals, you would have to put the 0 in there. Okay, but they didn't say in the question. Okay, in D they gave us a diameter, which is 257. So then you can use pi diameter. Okay, 1 mark for this formula. Pi times 257. Pi times the diameter. And then if you do that, pi times 257, you again are just going to press SD and you will get 807.39. Do you agree? Because the next number is a 9, we must round up. Okay, so 807.39. Remember your units, guys. When it comes to perimeter and area, they do take a mark off if you don't put the unit. Okay, so if you didn't write them, you can please add it now. That's important. Okay, any questions on that first one? Now, number 2 was a kind of like a word problem. They told you I can't remember the name of the person now, but someone has to run circuits around a track, right? She's running, and it's a circular track. So they were asking what the length of one circuit would be if the diameter of the track is the radius of the track was 88. So this was also given. So the radius was 88 meters. Now guys, if you're thinking of a circular track, right? Say this is how the track looks. It's a circle. Now she must run all the way around. Okay, so she's running to the starting point. Does it make sense if we're calculating the circumference of that circle to get the length of the circuit, right? The length that she's running. I'm not going to do area. We haven't done area yet. But they could ask you this question in the test for exam. And you need to understand that if she's running all the way around the circular track, you have to calculate the circumference to get the length of that circle. Okay, does that make sense? All right, so you need to know firstly that one circle is this circle. You don't have to write this top line, right? This is just like an explanation, right? Okay, you won't get a mark for that. You have to know the formula because they gave us the radius of the track. We're using 2 pi radius. Okay, so 2 pi times 88. Type it into the calculator. Now for this one, they say round to the nearest meter. So if we do that, 2 pi times 88, and you get your SD 552,9. So we agree that we must round this up now to the nearest, right? Because it's a 9. If that was like a 4, we would say 552 meters. Okay, but because this number is 5 or bigger than 5, we have to round up. So 553 meters. You don't even have to write this step, guys. You can just go straight to the final answer. Okay. So if you see this on the calculator, you can say, okay, I'm going to round up 553 meters. Or, yeah, 553. Does that make sense, guys? For that one. Now for the next one, they said for her training, she has to run 12 kilometers. How many times does she need to run around this track? All right, to fill up 12 kilometers. Now guys, 12 kilometers, we're going to need to use the circumference. Our circumference was in meters. So we can't work with kilometers and meters. So 12 kilometers I converted to meters. Do we agree that it's 12,000? Okay, there's 1,000 meters in 1 kilometer. So 12 kilometers will be 12,000 meters. So first do that conversion. And then guys, if she needs 12,000 meters, one circuit is 553. How are you going to calculate how many circuits you need? You're going to take the total number of meters that you need, and you're going to divide it by one circuit, that length. All right, so this is the total length that she needs to run. This is the length of one circuit, and that will give you 21.7. I think they said round to 1 decimal point. Let me just check. 12,000 divided by 553. Yeah, it was 21.698. All right, so that is 21.7. So guys, if they said we must round to the nearest number of circuits, what would we do for that? Would it be 21 or 22? 23. Yeah, because it's a comma 7. We would have to round that. Any questions on that one? Okay, number 4 was easy. The only thing with number 4 is that the radius was a funny value. Okay, so they're asking the circumference of a circle if the radius is 20 over 5. So guys, you mustn't just put all 5 values the radius. You know your formula, right? 2 pi times radius. So use 2 pi times the radius that they gave you, which is 20 over 5. Now you can type that into the calculator. I'll show you now how you can just do it in your head. You guys know how to do a fraction on the calculator? Yeah. Let me just show it for those of you that don't. So you'll do 2 pi times 20, and now you're going to press that button there. Do you guys see that button? It's like a fraction. Oh, sorry, wrong one. That one. And then it puts that 20 at the top. Okay. So now, if you wanted to move, you can use your arrow button to move with this calculator, which is quite nice. But we have to put a pi at the bottom for shift, and we press that pi button, and then we get our answer. Okay, which is just 40. So 40 centimeters. But guys, what you also could have done is if they said here without the use of a calculator, they could have. Do we agree that 2 pi is the same as 2 pi over 1? Okay, is that true? Times 20 over 5. Do we notice I'm doing a pi at the top and a pi at the bottom? Do we remember what happens there? We can cancel them out. Okay. So then what am I left with? 2 times 20, which is 40. Okay. So the circumference here was 40. For the next one, I think this is a cricket field or something, and they said that there is a boundary rope around this field in the shape of a circle, which is how it works anyway. They wanted to know the length of the boundary rope if the diameter of the field was 94 meters. Right? So now they've given you the diameter, so you use pi diameter. Right? Does that make sense? It's important, guys. Depending on the value that they give you, that's going to tell you which formula to use. Okay. So the length of the boundary rope, it's just like this concept here, right? When she was running around the track. Now you just have a rope going all around in a circular shape. So the length of that rope is the circumference of the circle. Okay, so the length of the boundary rope is the circumference of that circular shape. So you're just going to do pi times the diameter that they give. So this one, I think they also said round to the nearest meter. So let me just check. Pi times 94 is 295.3. So do I round up or down if it's a 3? Down. Okay, so that's why it's just 295. If it was a 5 or a number bigger than 5, you would round it up to 295. Any questions, guys? No questions. All right, we are going to move on to area now. We're not done with perimeter. You also going to practice it, but we're going to do them kind of mixed together. So you can write area as your next heading. The same as. Okay. I'm going. I'm going ready. What's happening? Let's go. Get ready. Guys, we are going to revise some of the formulas that you know already. I know you know how to find the areas of certain shapes. That's fine. But then we're also going to do some new ones that you haven't done. Well, one new one. Okay, square. Can we draw a square, guys? Just take a ruler and draw a square for me, please. It doesn't have to be perfectly to scale, but at least make it kind of look like a square. So guys, what is the main property of a square? What is the thing that makes a square square? Yeah. All the sides are equal. All right, so let's fill that in on the picture when you guys are ready. I'm just going to put a little line on each of those sides just to indicate that all four of those sides are equal. All right. Do we know any other properties of a square? Yeah. The angles do, yes. I was looking for something a bit more specific. It is correct though, yeah. All the angles are 90 degrees. So guys, let's add that in. Just make a little block in each of those angles. We are going to look at different quadrilaterals in more detail later in the year. So don't stress about this too much now. I just want us to fill like the basic properties in. And guys, I'm just going to use an S to indicate the length of these sides. So if I say that that length is S, do we agree that all of them are going to be S? Right? Because they're all the same. Because it stands for side. But also it stands for sky. Alright, so the area of a square, guys, you have to know this formula. I'm sure you do already. You can tell me what it is? Yes? Length times breadth, yes, but now I'm using an X and an S, right? Yes? Yes. Okay, so side times side. And we know that when you multiply something by itself, you can write it as side squared. Okay, but guys, if you want to use length times breadth, that's perfectly fine. It's just a side times side now. Okay. But it will be that side times that side. Alright, let's do the next one. What other shape do we know, guys? A triangle, okay. Okay, now guys, for triangle, I'm going to draw a few different pictures, okay? It will be a different type of triangle. So, how many am I going to draw? I'm going to draw three different triangles, okay? To make sure that you can put three triangles next to each other or underneath one. So for the first one, I'm going to draw a right angle triangle. Guys, thank you. What is that little symbol next to the H? Okay, good. We did discuss area of a triangle. I tried to erase it there. You can kind of see what we did there on that board. Alright. So we So we did speak about this the other day. Okay, so we have a bit of experience in that. Now, guys, unfortunately, they're not always going to give you a right angle triangle. If you have a right angle triangle, it's very easy to find the area, right? You take your one side and then you take the other side that is perpendicular to that one. Now, if we were working with Pythagoras, remember we did that whole shape that was like 3 right angle triangles put together. Okay, so we have practiced this already. What is the area, guys? What's that formula? Half times half base times perpendicular height. Okay, so half times whatever side you choose as the base, and then whichever side is perpendicular to that base. All right. But now they can also give you a triangle that is not a right angle triangle. So I'm going to move to the side slightly. They can give you one that's kind of like, you can draw almost like an isosceles triangle. It doesn't have to be isosceles really. It's just that kind of shape. Right, just like a normal triangle, okay? Just an acute angle triangle. Yeah. So guys, in this case, I know that the B stands for base, right? And often people think that means that it has to be the side that the triangle is like standing on. That's not always the case, right? The base is always the side that you have a perpendicular height for. Okay, we'll see when we do some more examples. In this case, guys, can I say that this side is perpendicular to this one? No, okay? That's definitely not a 90-degree angle. What about this? Are these two sides perpendicular to each other? No, maybe, all right, but they didn't tell us that that's a 90-degree angle. And what about this one? Also not, okay? So here we don't actually have that the perpendicular height is the side of the triangle. In this case, now I need you just to draw a dotted line going from that top point perpendicular to the bottom side. Okay, just draw it like that. It can be a lot as long as it's a cute angle. So guys, if your triangle isn't perfectly isosceles, then this line won't go like to the middle there. It's fine, it doesn't have to. It doesn't matter. I don't know, I just do it fine. It doesn't matter. Now this, guys, is the perpendicular height. That dotted line. And there's a lot of chatting. Can we stop, please? Especially in that. So guys, if we ask you to find the area of a triangle that is not right angled, they will have to give you a perpendicular height. Okay, which is in this case, so we see that the perpendicular height is not a side of the triangle. Okay, it's literally, if you take from the bottom to that top point, it's literally the distance between the base and that top vertex. Okay, that is the perpendicular height. So you can put here on the side, because it's going to become quite important when you draw our next picture. Perpendicular height is the distance between base and opposite point. Okay, does that make sense, guys? So literally the distance, not necessarily a side of the triangle, but the height of the triangle. Okay, if you have to take a ruler and you have to measure how high this triangle is from the floor, it will be that height. Okay, so the perpendicular height is not always the side of the triangle. All right. Now, if we're drawing an obtuse angle triangle, guys, just put your phone on silent, please. If we are now next drawing an obtuse angle triangle, so that kind of shape, Doesn't matter what the lengths of the sides are, just make sure that you can see that it is obtuse angle. What is an obtuse angle triangle? One of the angles here are bigger than 90. Okay. So acute angle, that's the middle one. All three angles are smaller than 90. Do we agree that for this one, this is an obtuse angle, this one is bigger than 90? Now guys, we are again going to say that this bottom side, if I put it in blue, that this bottom side is the base, but again, it doesn't actually matter. You can use any of the three sides as your base, as long as you have a perpendicular height on that base. Now guys, do we think that one of these two sides are perpendicular to my base? Is that a 90-degree angle there? No. And what about that one? Definitely not. So again, neither of these two sides can be the perpendicular height. So now, if I'm saying this is the base, right? What did we say now? Perpendicular height is the distance between the base and the opposite point, right? Which point is opposite this side? That top one, hey. Now, if I draw a perpendicular height now, do you see where it's going to go? It's not even going to be inside my triangle. It's going to be next to it. Okay, so draw a dotted line going from that top point to in line with your base. And then put that 90-degree angle. Maybe let's also do a little dotted line going towards the triangle. Remember guys, the perpendicular height of a triangle is literally the height of it from the base to that top point, right? So do we agree that that will be the height of the triangle? That is how high the triangle is. Okay, so even though it's now a line, a dotted line, that's not inside the triangle, that's fine, it doesn't matter. Okay, it has to be literally the height of that triangle. Okay. So those are the three different types of diagrams that you can get. So now, for this area, guys, you're not going to take that as your base. The base is a side of the triangle. Okay, that's important. The base always has to be a side of the triangle. So this is going to be your base. That side there. It doesn't include this little dotted part. Can you focus, please? Alright, so this base has to be a side. The perpendicular height doesn't have to be a side. Okay, but the base is definitely always a side of the triangle. Okay, let's just quickly write underneath here and underneath the other one as well. We just write underneath the middle one that the area here again is half base times perpendicular height. And we'll take half of that side, multiply by that length. And that will give you the area of the triangle. And then we can do the same thing for the middle triangle, right? So just underneath area here again is half base times that perpendicular height. So that side of the triangle times the actual height of the triangle. All right, we have one more shape to write down that you would have done in primary school. What's the other one that you haven't done yet? A rectangle, right? We've done square, triangle, rectangle. That's the third one. Now, a rectangle is very similar to a square. Okay, number 3, rectangle. So just draw a rectangle then, please. Make sure that it looks like a rectangle. Now guys, for this one we use length and breadth, okay? So you can use a normal L. I just always do like a cursive L so that it doesn't look like a 1. Okay, because you might misread it if you just put like an L that looks like that. It's fine if you do, just remember that it's an L there. I always use a cursive one. And then the breadth will be the other side. And then we have the same length there and there. Okay, we actually already worked with rectangle the other day as well. We did that straight shape, but we worked with the perimeter. Okay, what else do we know? Okay, let's actually put a little line here and then sorry, I forgot about that. And 2 lines there, 2 lines there. Just to show that those opposite sides are equal. And then what else do we know about a rectangle, right? What angles does it have? Also 90-degree angles. Hey, let's put that 90 in all of those corners, please. That little block. What's the formula for the area of a rectangle? Length times breadth. Okay, now the last one, number 4, circle. That is one that you have not done yet before. Some of you might have. Circle, so please just draw a circle. You can just do one with like a French cap or something if you have. Okay. It looks nice, huh? Of course it will. Guys, when you draw a circle, now if you use the compass, then the hole is going to be at the center of the circle, right? But if you just drew one like using a print cap, then just kind of guess where the circle is. Just make a little point where you think, sorry, not the circle, the center of the circle is. Mine can maybe go a little bit down. It doesn't matter, just kind of, oh dear, that's something else. Okay, just kind of guess there what the center is. Okay, another thing is, yeah. And now what I need you to do, from the center, draw a straight line to the circumference of the circle, to the edge of the circle, using a ruler, please. What would I call that line? The radius, hey? Oh, let's call that in. Okay, the area of the circle. Oh, you're trying to so pi r squared. Thank you. Okay, just calm down, please. The area is pi r squared. I think so much traffic, please. I'm gonna do it. And you stop. Ready? Ready? You as well, please. Everyone. Thank you, Martha. You don't need to get involved in. So the area is pi r squared. What is the r? Radius, eh? So guys, I'm worried that you're going to get confused with 2 pi r and pi r squared. Okay? Remember that when you find the area of something, the unit is always squared. You remember that? So if it was given in centimeters, the area is going to be centimeters squared. Okay, so that is why the area formula has a radius squared in it. Okay, that is maybe a way of remembering that the radius squared is because you're going to have like a centimeter squared or a meter squared or a millimeter squared, whatever it is. Whatever a unit they gave you, you'll square that for area. Okay, so that's a way of remembering which one is circumference and which one is area. All right, we're going to practice using these formulas now. I'm just looking for one that's not too hectic. Let me check. Maybe there's a nice exercise in the notes just to get us started. Okay, again, exercise 16.2, which that's a circle. Okay, sorry, let me just write this here. Exercise 16.1 is on page 186. I would like you guys to do number 63. Number 3 and 6. Now guys, in number 6, they've given you like an arrow shape, right? I'll just show you quickly. Do we have the formula for the area of an arrow? No, hey? Ryan? Okay, let's come down, Ryan. Page 186. Okay. A rectangle and a triangle, hey? Good. So you're going to have to find the area of this triangle and the area of this rectangle. Guys, I haven't given you the lengths of all the separate sides, hey? So let's quickly see. The breadth of the rectangle, sorry, is 3 centimeters. Do we see that thing? But now, what about the length of the rectangle? Because this whole thing is 17, Ryan? Minus 5, right? Good, because this section, this triangle is 5 centimeters, and that's going to be 12. Okay, so the length is 12, the breadth is 3. Now, what about the area of this triangle, guys? This is like our second picture. You see that? An acute angle triangle. So the base of this triangle is going to be this side here, which is what? 11, right? Good. Do we see that? The length of that base is 11. And what is the perpendicular height, guys? From the base to the top point? 5. Okay, so the base of the triangle is going to be 11 centimeters, and the perpendicular height is the actual height of that arrow top part, right? Which is going to be 5 centimeters. Okay, that's how you do number 6. Then I would also like you to do exercise 16.2. Sorry, there's multiple exercises, but each exercise is very short. So I have to kind of pick and choose. Page 190. Now for number 1, we've already done the perimeter, guys. Now you're going to do the area for number 1. That's the one that we just marked. Okay, but we just calculated actually the circumference. So I would like you to find the area there. Then 3 and 4 are interesting questions. See if we can figure those out. I'm going to give you the rest of this lesson now, so you will be able to either finish or do the majority of these questions in the time that is left. 16.3 on page 193. Number 1. Right, you have all the formulas that you are going to need, all right? So you are just applying the formulas, but in some cases, like with the arrow, you need to split it up into different shapes and first find out what the lengths of all of those sides are in order to find the area. Okay, if you don't have a textbook yet, make it fast. Or guys, I'm giving you 2 minutes to sort yourself out. If you don't have a textbook yet, to find someone that doesn't take a picture, or you